So guys, let's start. And all of you know that we are here to discuss about DNA Center. So first of all, DNA stands for Digital Network Architecture Center. Yes. All right. So DNA Center stands for Cisco Digital Network Architecture Center. Before discussing about the DNA Center, we'll start with the introduction of software defined networking. First of all, introduction of software defined networking. All right. So all of you know that what is a network. If I start from very basic concept, so we know that what is a network, right? So a network is group of devices connected with each other using some sort of medium or some sort of medium. All right. That media can be wired or that can be wireless. This is the basic definition of a network which we learn in ccna. All right. Now I'll say what is a software defined network. What is a software defined network? Or we can say a network managed and configured using a software is known as software defined network. So basically, what is software defined network? A network managed and configured using a software with the help of a software. That network is known as software defined networking, which you can say software defined network. And the whole process, which includes the functions, is known as networking. Simple. Now, we have two types of network: traditional network, and we have the software defined network. Because as we know that in networks we have router and switches. All right, we can have firewall or other devices as well. So if I say I have one router and I have one switch, one router and one switch. So now how we can make the configuration? So basically this router or this switch can be accessed through the console port, you know that, right? Or this device or this router can be accessed through telnet or SSH. So in the traditional network, what is our approach? Basically what we do, we use console cable or telnet SSH, and we use a laptop. In this laptop I can install a software like putty or any other software. It's your choice, but I using putty to access the devices. So in putty you can open the console access, or you can open the telnet or SSH access. This is how you can make the configuration on the routers and on the switches. But the configuration is not the challenge. So only configuration is not the challenge. There are multiple things which we have to look after, so that we can manage and we can build the network from a centralized location using a software. All right. So this is how we are trying to access the devices, and this is how we make the configuration, because configuration is the first step. Now I'll discuss what kind of configuration we make. I'll discuss about it just after 5 or 10 minutes. But this is how we deal with the network devices. But if I talk about software defined networking, and I have router and switches. This is my router again, and this is my switch. All right. Instead of making configuration using console or telnet SSH, what I'll do, I'll connect them with the network. Don't think that this is an ISP. It's just my internal network. And what do we have this time? We have a network controller. We have a network controller here. By using that network controller, what I'll do, first of all, I will add my router and switches on this controller. And after that, if you want to make any configuration on router or switch, you will be doing that task using this network controller. So now you guys might be thinking about what is the network controller, how does it looks like, right? How we can implement the network controller in our network. We'll talk about it later on. But right now, just think it like this: we have a device who is running some sort of software. Like this is my desktop. I am running Windows, right? So what is Windows? Windows is software. Mac OS, Linux, all of them are softwares, right? So likewise, a network controller is just a software which require physical resources like RAM, ROM, hard disk, all right, and the network interface cards. After that, you can raise to network controller, and network controller can push the configuration. So what we are trying to achieve here, first of all, let me give you an overview of the LAN network. All right. So in LAN network, mostly we are following an architecture. So we have two-tier architecture, and we have three-tier architecture. All right, and I hope all of you know about it, like what is a two-tier architecture and what is a three-tier architecture. So in two-tier architecture, we have two layers. First layer is access layer. This is my access 1. This is my access 2. And this is my access layer 3 switch. All right. And then I have the distribution layer here. Distribution 1 and distribution 2. Now I'll connect my access with distribution 1, access with distribution 2. Distribution 1 with access 2, access 2 with distribution 2. Likewise, we'll connect access 3. All right. So this is how we build a network. And now all of the users will be connected at the access layer. Right. Now, now I'm asking a simple question from you guys and just give your answer in the chat box. Do we need to make configuration in this network, or this whole network will be working as plug and play? Let me repeat myself. Do I have to make some configuration? We have to make some configuration, guys. We will be configuring VLANs, right? Like this user is in VLAN 10, this user is in VLAN 20, this user is in VLAN 30, VLAN 10, 10, 20, 30, 20, 20, likewise, right? So I will be making the VLAN configuration. For VLAN configuration, I can configure VTP, right? And then I will be configuring all of these links as trunk, 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 and trunk. All right. Then I will be configuring the routing, because I want to send traffic from VLAN 10 to VLAN 20 or VLAN 20 to VLAN 30. So for that we have to configure routing as well. And to configure the routing, I will be creating SUI interface on the distribution layer switches, which are known as switch virtual interface. Then I want to assign IP addresses dynamically to all of these users. So assign the IP address dynamically. What I will be doing, I will be having a DHCP server in the network as well. So I have to set up a DHCP server, and what I can do, I can configure distribution layer switches as DHCP server as well. For that, we just have to create a DHCP pool on distribution 1 and on distribution 2. All right. So I will be configuring DHCP here. Then you know that all of the users will be going to their default gateway first. After that, they can go to other networks. So for that, what I'll do again, I'll configure HSRP, VRRP, or ZLPP here. For example, HSRP or VRRP for gateway redundancy, right? What else? If you want to add something, you can drop a comment in the chat box, right? We can also configure VLAN ACL just to control the traffic in a VLAN. All right. We are running STP as well, so we can make changes in STP. Like if you guys know about STP, you have to configure distribution layers which is as a root bridge. So you have to make the changes appropriately, right? This is how we have to make the configuration first. And again, if may I ask you how you will make the configuration? Again, what you will say, you'll say that we'll access the distribution one, then we'll make the configuration. We'll access to distribution 2, then we will make the configuration, then we'll take access of A1, A2, A3. This is how we will access each and every switch separately, and we will execute the commands. This thing is known as traditional approach. All right, this thing is known as traditional approach, or you can say this thing is also known as distributed configuration model. Distributed configuration model. Distributed configuration model means the configuration of devices is has distributed, right? You have to configure them separately, or you can say you have to configure them individually. So that's why we call it distributed configuration model. So in a network, if you're following three-tier architecture, it doesn't make any difference in this approach. The difference is that in three-tier architecture, you have the access layer, you have the distribution layer, and you have the core layer, C1, C2. All right, that's the only difference. Again, you can see now number of devices has been increased. Number of devices has increased. Likewise, the number of configuration commands, because now you have to configure 3 to 5 and to 7 switches only. And now you guys are not asking any question because we can have the wireless as well, right? I'm not including wireless right now because it will create the complexity in the network. But yes, in real-time networks we'll have wired and wireless both. So I'm using wired technology as well as I'm using wireless technology. So for wired and wireless, what we have to do? We have to add the access points, APs. All right, we have to add AP in the network, access point. But don't worry about access point because you guys know about like WLC, right? Wireless controller. Right, we have the DNA Center and the Viptela solution are very new, but the wireless controller is here from last I think 10 to 15 years. So we have a solution for the APs, but for APs we can deploy a WLC, which is known as a controller for access points. But still, then we'll have to manage the WLC as well, because the configuration is centralized for the access points. But we have to make the configuration on WLC. So all of the access point will go to WLC for their configuration. We'll discuss about it because we have two types of access point. We have the, you can say we have autonomous access point and we have lightweight access point. So WLC is required for the lightweight access points. To manage lightweight access points, we can have a WLC. All right. But still, switch 1, switch 2, distribution 1, distribution 2, all of them needs to be configured separately. That's why this thing is known as distributed configuration model. Now, my next question is that who will make the configuration? Who will make the configuration? Yes, guys. So, okay, no answer as expected. Alright. So, who will make the configuration? Network engineer, yeah. Right. Now, you know that involvement of network engineer in each and every task. So, this is a network engineer who will be configuring your switches, who will be configuring your routers, firewall, access point, DHCP, NTP, right? All of this configuration. Or you can have the WLC, load balancer. So only this guy is responsible to make the configuration. And right now I haven't introduced you guys with the configuration which is required to manage the network. Like if I talk about syslog server, right? If I talk about SNMP server, you have to deploy an SNMP server. You have to deploy an NTP server. Syslog server or SNMP server are required to collect the log messages, right? You can collect log messages. For log messages, we have the severity level from 0 to 7. All right. We have the debugging as well. To collect the debugging log, again we require syslog server or SNMP server. Then NTP server is also there. So for a fully functional network, we have to make loads of configuration in the network. And the only thing or only approach we are following is the traditional approach, where we have a network engineer and that network engineer is responsible to make the configuration on switch, router, firewall, AP, DHCP, NTP, WLC, and load balance, right? So we have to change this approach. We have to change this approach. All right. You guys can see the screen now. So right now, in traditional approach, or you can say in the distributed configuration model, the configuration is mainly on the hardware centric. All right. Second thing, the whole configuration is manual, closed, because you know that distributed configuration model, or you know that the configuration is independent. There are two actions: reactive, proactive. Reactive and proactive. So if we see here, right now configuration is hardware centric, we want it to software driven. Configuration is manual, we want it automated. The configuration is closed because we don't have any variable or any other thing, but we want to make it programmable. Reactive. Reactive means if something will happen, then we'll only react according to that, right? But in case of the software defined networking, the software will continuously monitoring the network, continuously keeping the record of the network devices health, amount of traffic, latency, all of that stuff. So the approach would be predictive, that okay, if the devices are behaving like this is the health ratio, this is the like packet drop rate, latency rate. So as per that database, you can take the appropriate decisions. So when we'll start discussing about the DNA center, then you guys will see that what this predictive means. Network intent. Now you know that nowadays our networks are, or you can say businesses are dependent on a network, right? So we have to make sure that our approach to make the configuration is also business intent, not only the network intent configuration. So that's why sometimes software defined networking is also known as IBN, intent based networking. Now what does it means? Intent based networking means that you just have the intention and forget about how it will be done. All right, your network controller will automatically do the work. Your intention must be clear. So now you guys can see here that intent based networking is taking the IT industry by storm. The concept revolves around signifying the intent of the businesses and automatically translating that intent into the appropriate corresponding networking task. This is a circular logic in that it captures the intent of the business and IT staff, then translate that intent into the appropriate policies that are required to support the business. This is what I'm talking about, right? Intent based networking. What does it mean? Your intention must be clear, all right? And leave other things on the software or on the controller. Once the policies are created, the next step is to orchestrate the configuration of the infrastructure. This includes both physical and virtual components. This then kicks off the final step, which is providing assurance, insights, and visibility to ensure the network is functioning properly. Like I told you, right? Because what controller will be doing, controller will be providing assurance, We'll talk about what is assurance, and I'll show you. I'll take you through the GUI of DNA Center. Because this is a loop in a sense, the logic uses continuous verification and supplies any corrective actions that are necessary to fix or enhance the network performance. That's why we call it predictive. That's why we call it predictive. Means we will continuously collecting the information from the network and we will make the appropriate changes. We are not following the reactive approach, we are following the predictive approach. All right. So now let's come back to the whiteboard here. Yeah. So we are moving from traditional to this approach. All right. Software driven, intent based, and this. DNA Center. All right. So guys, what we have, mainly we have three types of network we talk about. Mainly, right? We have local area network, we have the wide area network, and we have the data center network. Mainly, you guys might be thinking, what about campus area network? LAN area network and campus area networks are very, very much similar, because local area network is a network which exists in a building or at a floor in small geographical area. And on the other hand, if we talk about campus area network is a big LAN, basically where we have many buildings, but again the whole network is under a single administrator, or you can say owned by a single entity. And again, it's just a big LAN, no third parties involved in that network. That's why campus area network and local area network are following the same approach, same technologies, same thing. Campus area network is just a big LAN network. And then wide area network, then data center network. Personal area network, metropolitan area network, we are not going to discuss about all of them. So local area network, wide area network, and data center network. So if we talk about local area network, we have already did. If we talk about that in local area network, we have already discussed, right? In local area network, we have the distribution layer, we have the access layer. Or if it is a campus area network, in that case, you can have A1, A2 access layer, distribution layer, and core layer. All right, that's the only difference. In campus area network, you will see core layer as well. If I talk about wide area network, so basically wide area network was designed to provide communication between the local area network separated by a large distance. This is LAN 1, this is LAN 2, this is LAN 3, this is LAN 4. Okay, this is your office, for example, this is Google network, This is you can say Facebook network, and this is our NS, for example. All right. So this is in Gurgaon, in Bangalore. So I have to access the Facebook server and I have to access the Google server, but as well as I want to access my Bangalore branch. So Gurgaon branch wants to communicate with Bangalore branch. So now the problem is here. If you talk about the distance, maybe they are 2,000 kilometer distance, right? Between, for example, 5,000 kilometer distance. Facebook, we have, we can say again 5,000 kilometer the distance. I'm just assuming it, all right? So I have two options. Either I have my own network, which is taking my data from one location to other location, which is not possible. That's why, that's why we have something known as service providers. We have something known as service providers. All right. I'm just telling you how the network is connected. Then we'll go back to DNA Center so that you guys can relate. Now we have ISP services like internet services, all right, and we have service known as MPLS. MPLS is mainly used to provide communication between two private sites, and MPLS stands for multi-protocol label switching. MPLS stands for multi-protocol label switching. And if we talk about data center networks, in data center networks, we have an architecture which is known as spine and leaf architecture. So here I have the servers, server 1, server 2, server 3. Then I have the switches and more switches. So likewise distribution, we have spine switches here. Likewise access, we have leaf switches here. Leaf 1, leaf 2, leaf 3. All right. And then we have access layer switches. Sorry, we have the servers. And inside of these servers, we have the VMs. I can't go into much details, but virtual machines, right? We have VMs inside the switch. So this architecture we are following in the data center networks. Now again guys, if I come back to the configuration part, I have routers over here, right? For security purpose, I have to deploy firewall as well. I have to deploy load balancer. There are multiple types of network, sorry, multiple type of devices over there. So again, who will make the configuration? Who will make the configuration on all of these spine switches? Again, you or me, right? We are getting paid for this like doing the configuration, and then we are also getting paid for troubleshooting the network as well. So we have implementation engineer, we have support engineer. So in implementation, you have to implement the network, you have to make the prior configuration, as a support engineer, you have to make sure that the network is in the operational state. All right. So again, the approach is same. Now, what Cisco did? Cisco, you know that Cisco is a multinational organization based in US. Cisco said that we have to change the way of network configuration and management. We cannot rely completely on the network engineer, because the problem is we have higher chances, or you can say long hours will be taken to make the configuration. There are higher chances of misconfiguration, difficult troubleshooting, or you can say troubleshooting is difficult, because you have to go each and every device and then you have to check it that okay, here it is working fine, here it is working fine, like this. So troubleshooting difficulties, you can say troubleshooting issues. More manpower is required. More manpower is required. So please let me know in the chat box. If I say I have to set up a LAN network, and in then that network, what I have to do, I have to add 75 switches. I have to add 100 access points. I have to provide IP addresses to 10,000 hosts. All right. And you must have separate VLANs. So we have to create around 50 VLANs over there. Then network policies. We have to make sure that user is authenticated. So user authentication. All right. There are hundred of things here. If I'll start counting, there are hundred of things you have to take care in a network. All right. So for more manpower is also required for that. Yes. So Cisco said we have to change the way of network configuration and management. That's why Cisco come up with the concept of software defined networking. Cisco come up with the concept of software defined networking. If I look for the software defined network definition, mm, 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 add text. All right. So you guys can see it here. What is software defined networking? Software defined networking is an approach to networking that uses software based controllers or application programming interfaces to communicate with underlying hardware infrastructure and direct traffic on a network. So basically, in software defined networking, we are using a software defined or software based controllers. And I'll talk about network controllers right now. So like I said, we have mainly three types of network. We have local area network, or you can say campus. We have, you can say, wide area network. And we have the data center network. All right. So for as Cisco, for campus area network, Cisco have controller which is known as Cisco DNA Center. All right, or Cisco is having a controller known as Cisco Epic EM. I'll discuss about Epic EM or all of that stuff. But for wide area network, we have Cisco Viptela solution. In Cisco Viptela solution, we have mainly three controllers. First controller is known as vManage, vBond, and vSmart. All right. And in data center networks, we have the Cisco Epic. We have Cisco Epic. So Cisco is having different controllers for different types of network. Now I'll say, okay, what Epic stands for? Epic stands for Application Policy Infrastructure and Controller. All right. Viptela was like a completely independent organization, but now Cisco has acquired Viptela. So that's why it is known as Cisco Viptela. Like Cisco acquired Meraki, that's why we call it Cisco Meraki. Cisco has acquired Catalyst switches or Catalyst series of switches, right? That's why we call it Cisco Catalyst. So that's why we have epic EM here. Basically, what is epic EM? Epic EM is just same controller, all right, but EM stands for enterprise module, because local area network is also known as an enterprise network. So we call it enterprise module. That mainly Cisco Epic was designed for data center networks, but it can be used to automate your local area network as well. That's why we call it Epic EM, enterprise module. And where Cisco DNA Center is a totally different software, all right? Or you can say software based controller. Cisco DNA Center is an you can say an appliance, or it is just a software, all right? Software based controller, all right? So all of them are software based controllers. Cisco Epic, Cisco Viptelas, all of them. But we need the hardware to run a software, right? Yeah. No, no. See, Epic was designed for automation of data center networks. All right. But what Cisco did, Cisco said, okay, if you want to automate your local area network as well, you can use Epic. But for that, you require enterprise module Epic. Enterprise module, yeah. Yes, yes. Yeah, yeah. Yes. Yeah, Viptela is a different solution. Cisco Viptela is for the wide area network automation. Okay. So in Cisco Viptela solution, we have three controllers mainly. We have vManage, we have vBond, and we have vSmart. So collectively, it makes the whole Viptela solution, which is automating the wide area network. Okay. But in this session, you know that our main focus is on DNA Center. Network controllers. Now you guys have the basic understanding that what is a network controller, what is DNS Center is used for, what is Cisco Viptela is used for, and what is Cisco Epic is used for, right? This is known as application centric infrastructure as well, ACI. Same thing. So network control. Mhm. Network controller is a combination of hardware and software which can be located on or off premises. You can say in data center or you can say on cloud. Alright. Network controller is mainly used to automate the network tasks like configuration, troubleshooting, monitoring, analytics, etc. Yes. So network controller is a combination of hardware and software which can be located on premises or off premises. First thing is that you don't need this controllers. That controller must be deployed in the local area network. If you're trying to manage the local area network, or it should be located in the wide, it can be located anywhere. As long as your network controller is reachable to the network devices, it can be located on premises or it can be located off premises. This is known as flexibility, and you know that we love flexibility, right? Must be flexible, like a class. If you're flexible with this timing, we can do it. If you're flexible with other timing, we have to compromise, but we have to change the timing, right? So flexibility is a best thing in the network as well. So that's why we have the flexibility in the network controller deployment as well. I can deploy my controller on my own network, but I can also deploy my controllers in the off premises. You can say in the data center or you can say in the cloud. All right. Yes. So no, same, same. The only difference is that the controller must be reachable. But for that you have to do like a NAT or VPN. Anyhow, the network devices must be reachable to the controller. That's the requirement. All right. Because only then your network controller can manage the whole network, or it can pass the configuration to the network devices. We'll talk about licensing as well, that how licensing works. Okay, we'll talk about it. Right now we are just talking about software defined networking. What is traditional approach, what is the new approach, types of network, then types of controller. All right, then our focus will be on only on DNA center. Okay, Nitish. Okay, then let's move further. Let's come to the DNA center now. So now I'm opening a present. Can I? All right. See, prerequisite. Before taking this course, you should have the following knowledge and skills. You should have an understanding of network routing and switching principle equivalent to the Cisco CCNA certification level, right? Because you know that in this course we will not be talking about IP addressing. I will not be talking about how the routing works, how the switches works. So basically, you must have the basic understanding of a network. All right. Yeah. So now this is the outline which was shared with you, right? All right. Exploring Cisco SDAccess. Now, what problems does software-defined access solves? First thing is basically right now it is talking about the network itself. They'll say what is software-defined access? Software-defined access, right? This is also known as SDA. So basically it is talking about the LAN automation. All right. As we say, software defined WAN, which is known as SD-WAN. So we have SD-WAN and we have SDAccess. SDAccess is referred to LAN network and SD-WAN is referred to wide area network. All right. So first thing it is talking about the security segmentation. But before that, we should discuss about software defined access. Then we'll discuss about what kind of problem it is solving. Okay. Yeah. So what is Cisco software defined access? Cisco SDAccess is the foundation for a new era of intent-based networking. Cisco SDAccess is an innovative fabric-based network infrastructure to provide automated network and policy configuration, dynamic host mobility for wired and wireless. Again, we'll have to discuss about all of these terms. Then identity-based macro and micro segmentation. What is segmentation? Then what is micro and macro segmentation? Then we have virtualized, multicast, and layer 2 broadcasts. Yeah. Along with the time we will discuss. So basically, if I talk about the architecture, here it is. This thing is known as campus fabric. All right. Here we have the switches, we have the router, we have the WLC, We have the other switches, and then we have access points as well. If you see here, right? All of these are access points. Again, switch, router, WLC, switch, switch, switch. Then you can see the IP connectivity, right? And in IP connectivity, then we have the Cisco DNA Center itself. So basically, mainly DNA Center is having two components. First component is known as NCP, and the other component is known as NDP. Do you have any idea about ICE? Yeah. So don't think that ICE is introduced by DNA Center. ICE is here for a very long time. But instead of that term reinventing the wheel, reinventing the wheel doesn't make any sense, right? If the thing is there, you can use that. If a wheel is there, I don't have to reinvent the same wheel. But what I can do, I can make modifications to it, right? So what we did here, we have the identity service engine already. But what Cisco did, Cisco said, okay, we need ICE in the network. So instead of deploying, or instead of creating all the features in DNA Center itself, what we can do, we can integrate our Cisco DNA Center with ICE. We can integrate our Cisco DNA Center with ICE. By doing this, what we can achieve, we can achieve all the functionalities supported by ICE. Yes or no? Yeah. So SDAccess. GUI approach provides automation and assurance of all fabric configuration, management, and group-based policies. I'll talk about that right now, how we identify an end user. Uh, do you know about some ACL, access control list, right? So you know that how we identify an end user in the network. We identify an end user always on the behalf of IP address, but this is not a better approach. Now in SDAccess Fabric, we have a totally different approach to identify a user and to enforce the policies for that user. All right, I'm not dependent on the IP address to identify a user. So we will be having what? We will be having groups. That's why we need ICE here. ICE is having something known as SGT, Security Group Tag. So we will be using that feature. Cisco DNA Center integrates multiple management systems to orchestrate local area network, wide area network, and WAN access network. Wide area network access. That how your traffic will be going to the wide area network. All right. Yeah. No, access of the wireless network, the traffic which is going to the wide area network. Yeah. No. Yes. Can be configured. Yeah. Yes. Then campus fabric. CLI or API approach to build a Lisp plus VXLAN plus CTS fabric overlay for your enterprise campus network. Now, to understand this thing, I have to discuss about overlay and underlay network. In SD fabric, in SDA fabric, we have two networks. We have underlay network and we have overlay network. So what is the difference? If I give you an example of this, do you know about VPN? VPN, virtual private network. All right. So this is my site one. All right. This is my site two, and I am connected using an ISP. You know, we always represent an ISP using a cloud. Why? Because we don't care what is happening inside this ISP network. But if I talk about it, you know that we have routers here, right? And we have switches here, nothing else, right? But we don't want to talk about it. That's why we always represent an ISP network using a cloud. Yes or no? So in this case, what I'll do, I'll create a virtual private network from this side to this side, right? So what is this VPN? So if I tell you that VPN stands for virtual private network. Virtual private network means that okay, you are able to send traffic from this R1 to R2 securely, but it doesn't mean that you have direct physical connectivity. Packet 1, packet 2, packet 3, packet 4 and packet 5. All right. That's why we call it virtual. So I call this virtual private network as an overlay network. And now what is an underlay network? Foundation network. Responsible for providing the hardware, infrastructure, and the connectivity, right? So underlay network is the foundation network which is responsible for providing the hardware infrastructure and the connectivity so that your overlay can work. You know what is the advantage of this? If we talk about VPN, if we talk about VPN, all right, yeah, that's the feature of VPN, right? Yes. Yeah. So if I say this is my network and this is R3, this is R4, this is R5, this is R6, this is R7. Right, Heather? Right, it is. Now this is my site, you know, site 2, site 3, site 4, site 5, site 6, and site 7. And all of them are using a LAN network behind them. Yes or no? For example, site 1 is using 10.1.7.0/24. It is using 10.1.6.0/24, 10.1.5.0/24, 10.1.4.0/24, 10.1.3.0/24, 10.1.2.0/24, and 10.1.1.0/24. But you know that ISP routers will not be having any idea of these networks, right? But still, but still, we are able to send traffic from this network to this network, from this network to this network, from this to this. How is it even possible? Because if this user 10.1.1.2, for example, wants to send traffic to 10.1.2.2, all right, and IP address of this is 101.1.1, and IP address of this public IP is 201.1.1, right? Now the ISP routers know about this IP address. So what will be happening here? The user will be sending traffic to the default gateway. All right. How it will look like? It will be look like this. Source IP is 10.1.1.2. Destination IP is 20.1. Or you can say 10.1.2.2. Right. This traffic will be given to the default gateway. Default gateway will say, okay, this traffic will go to other site. So how we can send it? We have to send it using the VPN tunnel. So what will be done here? It is this 10.1.1.2 destination is 10.1.2.2 will be encapsulated with GRE if you are using GRE, right? And a new IP header will be added 101.1.1 and 201.1.1.1. So when this traffic will be given to the ISP will say, okay, we have to go to 201.1.1.1. ISP router will not check the internal header, right? Then traffic will be forwarded to R2. R2 will remove this header and then the remaining packet will be given to this. What happened here? Basically, I am identifying all of these users on the behalf of a single IP address, right? On the behalf of single IP address. It means this ISP network doesn't require information of each and every private network which is behind the as routers. So overall, it reduces the load on the network devices, or you can say on the routing table. Right, Nitesh? So in this, I was talking about CLI API to build a Lisp VXLAN. Lisp VXLAN. Okay. For that, Let me discuss the traditional approach. The problem we are facing in the network nowadays. If I start from very basics, this is my switch 1, this is my switch 2. What we are doing in the LAN network, Nitesh, we are using layer 2, right? See, we can talk about DNA center, but first we have to build the foundation, okay? So don't think that, okay, we are here to discuss DNA, but where is the DNA center? I'll take DNA center here, don't worry. But I'm just trying to building the foundation. Now, this user is in VLAN 10, VLAN 20, VLAN 20, 10, 20, 10, 20. MAC address of this user is A, B, C, D, E, F, G, and H, right? And we are using layer 2 between distribution and access. So what is the problem in layer 2? The biggest problem is broadcast, right? Because a switch is having a simple rule. If a broadcast frame is received on one of the interface, that broadcast will be forwarded out of all other interfaces. Okay, and that will create an endless loop. So the broadcast traffic create a layer 2 loop. And you know what layer 2 loop? Layer 2 loop is an endless loop. If I compare it with layer 3 loop, because in layer 3 we have a value known as, sorry, not MTU, it is TTM, sorry, time to live. The layer 3 loops can be discarded automatically, but the problem is with layer 2 loops. Layer 2 loops are endless loops because we do not have any TTL value over there. Right, Nitesh? Now, we have to add a new protocol which is known as STP. So all of the ports will become DP, RP, alternate, RP, alternate, DP, DP, RP, alternate. Because I'm assuming that D1 is my root, right? So what is the first problem? The first problem is that I won't be able to utilize all the links. I won't be able to utilize all the links. Second problem, the switch will maintain a MAC address table, right? So the switch will be having information of MAC A, MAC B, MAC C, and MAC D. Then D1 must have information of MAC A, MAC B, MAC C, and MAC D, right? D2 must have information of MAC A, MAC B, MAC C, and MAC D. Likewise, switch 2 will have the information of A, B, C, D, all of the MAC addresses, right? Because by default, what we are following flood and learn behavior, if you know about it. By default, a switch or user send a broadcast request, broadcast is forwarded to every switch, then the end user give a response, and this is how we build the MAC address table. This is how we build the MAC address table, right? Now, this is known as flood and learn behavior. Again, we have 4 users here, so we must have the MAC address of E, F, G, H. EFG H EFG H. Okay. If may I ask you, Nitesh, that for example I have 10,000 users. How many users? How many MAC addresses will be in the switch 1, switch 2, switch 3, switch 4 MAC address table? 10,000, right? Is it a problem? Bigger MAC address table, right? And it will take that much time to find out the exit interface. It doesn't like this. Okay, this MAC is D, D is here. No, it will check from the first to last. Yes or no? Yes. So that's the problem by default. So in SDA fabric, I'm not talking about SDA fabric. This is the traditional approach. Okay. In SDA fabric, we are not using layer 2 here. We are not using layer. You will say, okay, if you will remove the layer 2, VLANs will also be removed, right? If I remove the layer 2 concept, VLAN concept will also be removed, right? But no, what we will be doing here, we will still be having the VLANs, but these switches will not be aware about the end user identities. Okay, they will not be aware about the end user identities because it would be very much clear to you when I'll talk about VXLAN. And I'll talk about what? VXLAN, virtual extensible LAN. Okay. So in SDA fabric, we will talk about VXLAN. We will also talk about Lisp. Locator ID separation protocol. All right, and we will also talk about CTS, which stands for Cisco Trust Sec. All right, Nitesh. And here, virtual extensible LAN will be used for the data plane traffic, for the user traffic. Okay. Lisp will be used for the control plane traffic, and Cisco Trust Stack will be used for the segmentation. Okay. So now you'll see we will not be running STP. We will not be running STP in the network. STP, stands for spanning tree protocol. So that's why it is saying you that in the campus fabric we will have the Lisp, plus we have the VXLAN, and then we have the CTS. CTS stands for Cisco Trust. All right. Now, CLI provides the backward compatibility, but management is box by box. API provides some automation by netcon for YAML, also box by box. So basically, if you know the basics, in a network devices we have basically three planes. We have management plane, we have the control plane, and we have the mainly we have two planes, control and basically management plane you can say is a sub plane of control plane. I can say it is just a sub plane of control plane, right? So what we did using the softwares or using the controllers, we have routers here, and we have the IP connectivity. This is not ISP, this is IP connectivity, okay? And the network controller. This is your R1, this is your R2, this is your R3, and this is your R4. This is the control plane, this is the data plane. Control plane, data plane, control plane, data plane, control plane and data plane. Alright, Nitesh. So what we did here, we have given the control plane of the network devices to the controller. So that what controller will be doing, controller will be controlling the control plane of each and every network device. Alright. And you know that working of data plane is dependent on control. So basically control plane is like we can say brain, right? Like in a human body we have a brain. If your hand or if your legs everything is very healthy, but if your hands and everything is not controlled by brain, you would not be able to even lift a pen, right? Because personally I have a child in my family. Data plane is totally dependent on the control plane, and we will be managing a control plane of each and every device from the controller itself. But you know what few people thinks that okay, control plane has moved to the controller, the device is having the data plane only. No, the device is still having the control plane. You can still manage this device locally. You can still manage this device locally. Okay. So the control plane is not moved to the controller. The device is still having its own control plane, but we are managing the control plane of the device through the controller. Okay. Okay, Nitesh. So that's why it is sorry saying that CLI provides the backward compatibility. Means still you can access your device by CLI. Still you can configure your device locally. That's your personal choice. Okay. All right. So that's all for today. In tomorrow class, we'll start SDAccess. What is a fabric overlay? What is a fabric underlay? What is SDAccess? What is DNA Center? All of these things. Okay. So tomorrow I'll discuss the SDA architecture and the problem solved by DNA Center. So I hope you guys have enjoyed the session.